wire size of number 2 THHN is appropriate based on the distance and load. This wire can handle the 2000 watts of power and a 9-foot run to the battery. Adding a second battery as a backup is a good idea. It will provide additional power capacity and ensure that you have power even if one battery fails. You can connect the second battery in parallel with the first battery using the same wire size, number 2 THHN. PVC conduit is a suitable choice for protecting the wire from physical damage and moisture. A 1 1/2 inch conduit would be sufficient to accommodate the number 2 THHN wire. To protect the wire from road hazards, you can route it under the chassis and then up into the engine compartment through a grommet. This will keep the wire out of harm's way and prevent it from being damaged by debris. Firstly, install a 20 amp circuit breaker or fuse between the transformer/rectifier and the battery to protect against overloads. Secondly, ensure that the transformer/rectifier is properly grounded to the chassis of the van. Thirdly, allow for adequate ventilation around the transformer/rectifier to prevent overheating. If you plan to charge batteries with the transformer/rectifier, use a compatible battery charger that is designed for the type of batteries you are charging. When selecting a wire size for electrical applications, several factors must be considered to ensure safety and optimal performance. These factors include ampacity, voltage drop, insulation type, and environmental conditions. Ampacity refers to the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The National Electrical Code, NEC, provides tables that list the ampacity of various wire sizes and insulation types. These tables are based on specific conditions, such as the ambient temperature and the number of conductors bundled together. It is crucial to select a wire size with an ampacity that is equal to or greater than the calculated load current. The load current is determined by dividing the power, in watts, by the voltage, in volts. For example, a 2000 watt load operating at 120 volts would require a current of 16.67 amps. Therefore, the selected wire size must have an ampacity of at least 16.67 amps. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using Ohm's law, which states that voltage, in volts, is equal to current in amps multiplied by resistance in ohms. The resistance of a conductor depends on its material, length, and cross-sectional area. Longer conductors and smaller wire sizes have higher resistance, resulting in greater voltage drop. To minimize voltage drop, it is necessary to select a wire size that is large enough to keep the voltage drop within acceptable limits. Insulation type refers to the material that surrounds the conductor and provides electrical insulation. Different insulation types have different temperature ratings and are suitable for different environmental conditions. THHN insulation is a common type of insulation that is widely used in electrical wiring. It is heat resistant, moisture resistant, and flame retardant. THHN insulation has a temperature rating of 90 degrees Celsius, which means that it can withstand temperatures up to 90 degrees Celsius without degrading. Other insulation types include XHHW, which is suitable for wet locations, and OFF, which is suitable for underground applications. The choice of insulation type depends on the specific application and the environmental conditions. Environmental conditions can also affect the choice of wire size and insulation type. For example, if the wire is exposed to high temperatures, it is necessary to select a wire with a high temperature rating. If the wire is exposed to moisture, it is necessary to select a wire with moisture-resistant insulation. If the wire is exposed to corrosive chemicals, it is necessary to select a wire with chemical-resistant insulation. In addition to these factors, it is also important to consider the dirting factors that may apply. Dirting factors are used to reduce the ampacity of a wire when it is installed in certain conditions, such as when it is bundled with other conductors or when it is exposed to high ambient temperatures. The NEC provides tables that list the derating factors for various conditions. It is crucial to apply the appropriate derating factors to ensure that the wire is not overloaded. When selecting a wire size, it is always best to consult the NEC and follow the manufacturer's recommendations. The NEC provides detailed guidelines for selecting wire sizes and insulation types for various applications. The manufacturer's recommendations may provide additional information about the specific wire being used. By following these guidelines, you can ensure that your electrical wiring is safe and reliable. Conduit is a protective tube or channel used to enclose and protect electrical wiring. It provides physical protection to the wires from damage, moisture, and corrosion. Conduit also helps to contain and manage the wiring, making it easier to organize and maintain. There are several types of conduit available, each with its own advantages and disadvantages. The most common types of conduit include rigid metal conduit, RMC, intermediate metal conduit, IMC, electrical metallic tubing, M, flexible metal conduit, FNC, and polyvinyl chloride, PVC conduit. Rigid metal conduit, RMC, is a heavy-duty conduit made of steel or aluminum. It provides excellent protection against physical damage and is suitable for use in both indoor and outdoor applications. RMC is typically used in industrial and commercial settings where there is a high risk of damage to the wiring. Intermediate metal conduit, IMC, is a lighter weight version of RMC. It provides similar protection to RMC but is easier to bend and install. IMC is often used in commercial and industrial settings where the wiring needs to be run through tight spaces. Electrical metallic tubing, EMT, is a thin-walled conduit made of steel or aluminum. It is lightweight and easy to bend and install. EMT is typically used in residential and commercial settings where there is a low risk of damage to the wiring. Flexible metal conduit, FNC, is a flexible conduit made of steel or aluminum. It is used to connect electrical boxes and equipment that are subject to movement or vibration. FNC is also used in areas where it is difficult to run rigid conduit. Polyvinyl chloride, PVC, conduit is a non-metallic conduit made of PVC plastic. It is lightweight, corrosion-resistant, and easy to install. PVC conduit is typically used in underground applications and in areas where there is exposure to moisture or corrosive chemicals. When selecting a conduit size, it is important to consider the number and size of the wires that will be run through it. The NEC provides tables that list the maximum number of wires that can be installed in a given conduit size. These tables are based on the wire size, insulation type, and conduit type. It is crucial to select a conduit size that is large enough to accommodate all of the wires without overcrowding. Overcrowding the conduit can make it difficult to pull the wires through and can also increase the risk of damage to the wires. In addition to the conduit size, it is also important to consider the bending radius of the conduit. The bending radius is the minimum radius to which the conduit can be bent without damaging it. The NEC provides guidelines for the minimum bending radius of various conduit types. It is crucial to follow these guidelines to avoid damaging the conduit and the wires inside. When installing conduit, it is important to use the proper fittings and connectors. Fittings and connectors are used to join sections of conduit together and to connect the conduit to electrical boxes and equipment. There are different types of fittings and connectors available for each type of conduit. It is crucial to select the appropriate fittings and connectors for the conduit being used. It is also important to ensure that all fittings and connectors are properly tightened to prevent moisture and dirt from entering the conduit. Grounding is an essential safety measure in electrical systems that provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. A properly grounded system ensures that metallic parts of electrical equipment, such as enclosures and conduit, are at a safe potential relative to ground. This prevents dangerous voltage from building up on these parts, which could pose a shock hazard to anyone who comes into contact with them. The grounding system consists of several components, including the grounding electrode conductor, and the equipment grounding conductor. The grounding electrode is a conductive object, such as a metal rod or plate, that is buried in the earth and connected to the electrical system. The grounding electrode provides a low resistance connection to the earth, which helps to dissipate fault current. The grounding electrode conductor connects the grounding electrode to the main electrical panel. It is typically a copper wire that is sized according to the size of the service entrance conductors. The equipment grounding conductor connects the metallic parts of electrical equipment to the grounding system. It is typically a green or bare copper wire that runs along with the circuit conductors. In the event of a fault, the equipment grounding conductor provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse. There are several methods for grounding electrical systems, including the use of a grounding rod, a grounding plate, or a metal water pipe. The grounding rod is a metal rod that is driven into the earth. It is typically made of copper or copper-clad steel. The grounding plate is a metal plate that is buried in the earth. It is typically made of copper or galvanized steel. The metal water pipe can be used as a grounding electrode if it is in direct contact with the earth for at least 10 feet. When grounding electrical systems, it is important to follow the requirements of the NEC. The NEC provides detailed guidelines for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for connecting grounding conductors. It is crucial to comply with these requirements to ensure that the grounding system is effective and safe. In addition to grounding the electrical system, it is also important to bond together all metallic parts of the electrical system. Bonding is the process of connecting together all metallic parts of the electrical system, such as conduit, enclosures, and equipment. Bonding ensures that all of these parts are at the same potential, which prevents voltage differences from developing between them. Voltage differences can cause electrical shock if someone comes into contact with two metallic parts that are at different potentials. Bonding is typically accomplished by using bonding jumpers, which are short lengths of copper wire that are used to connect together the metallic parts of the electrical system. Bonding jumpers should be sized according to the size of the circuit conductors. Ventilation is the process of providing fresh air to an enclosed space and removing stale or contaminated air. In electrical systems, ventilation is important for preventing overheating of electrical equipment, such as transformers, rectifiers, and power supplies. Overheating can damage electrical equipment and can also pose a fire hazard. Electrical equipment generates heat as it operates. If this heat is not properly dissipated, it can build up inside the equipment and cause the temperature to rise. High temperatures can damage the insulation on wires, reduce the lifespan of components, and even cause the equipment to fail. Ventilation helps to remove this heat and keep the equipment operating at a safe temperature. There are several methods for providing ventilation to electrical equipment, including natural ventilation, forced ventilation, and air conditioning. Natural ventilation relies on natural air currents to circulate air through the equipment. This can be accomplished by providing openings in the enclosure of the equipment that allow air to enter and exit. The size and location of these openings should be carefully designed to ensure that there is adequate airflow. Forced ventilation uses fans to circulate air through the equipment. This is more effective than natural ventilation, especially in situations where there is limited natural airflow. Fans can be installed to blow air into the equipment or to exhaust air out of the equipment. The size and type of fan should be selected based on the amount of heat that needs to be removed and the size of the enclosure. Air conditioning can be used to cool the air that is supplied to the equipment. This is the most effective method of ventilation, but it is also the most expensive. Air conditioning is typically used in situations where the equipment generates a large amount of heat or where the ambient temperature is very high. When designing ventilation systems for electrical equipment, it is important to consider the following factors: the amount of heat generated by the equipment, the ambient temperature, the size and location of the equipment, the type of enclosure, and the airflow requirements. The amount of heat generated by the equipment can be determined from the manufacturer's specifications. The ambient temperature is the temperature of the surrounding air. The size and location of the equipment will affect the airflow patterns. The type of enclosure will affect the amount of ventilation that is required. The airflow requirements are the amount of air that needs to be circulated through the equipment to keep it operating at a safe temperature. In addition to providing ventilation, it is also important to keep electrical equipment clean. Dust and dirt can accumulate on the equipment and reduce its ability to dissipate heat. The equipment should be cleaned regularly with a vacuum cleaner or a soft brush. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect high-voltage circuits feeding an entire city. Circuit breakers are an essential component of any electrical system, providing protection against overloads and short circuits, and helping to prevent electrical fires and other hazards. There are several types of circuit breakers, each designed for specific applications. The most common types include thermal circuit breakers, magnetic circuit breakers, and electronic circuit breakers. Thermal circuit breakers use a bimetallic strip that bends when heated by excessive current. This bending action trips the breaker, interrupting the circuit. Thermal circuit breakers are typically used for low current applications, such as protecting household appliances. Magnetic circuit breakers use an electromagnet to trip the breaker when excessive current flows through the circuit. The electromagnet pulls a latch, which releases the breaker mechanism. Magnetic circuit breakers are typically used for higher current applications, such as protecting electrical panels and feeders. Electronic circuit breakers use electronic components to detect overcurrent conditions and trip the breaker. These breakers offer more precise and faster protection than thermal or magnetic breakers. Electronic circuit breakers are often used in critical applications where fast response time is essential. When selecting a circuit breaker, it is important to consider the following factors: the voltage and current rating of the circuit, the interrupting capacity of the breaker, the type of load being protected, and the environmental conditions. The voltage and current rating of the circuit breaker must be equal to or greater than the voltage and current of the circuit it is protecting. The interrupting capacity of the breaker is the maximum amount of current that the breaker can safely interrupt. The interrupting capacity must be sufficient to handle the potential fault current in the circuit. The type of load being protected will affect the type of circuit breaker that is required. For example, motors require circuit breakers with time delay characteristics to prevent nuisance tripping during startup. The environmental conditions, such as temperature and humidity, can also affect the performance of circuit breakers. Circuit breakers should be installed in accordance with the NEC and the manufacturer's instructions. It is important to ensure that the circuit breaker is properly sized and installed to provide adequate protection for the electrical circuit.